Okay, thank you very much for asking me to talk to you today about cleaning and disinfection. And I hope to cover some of the points that have been raised by both Martin and Richard. Just a little bit about SARS-CoV-2. Obviously, we've got some participants here that don't know an awful lot about the virus. So I thought I'd give a brief explanation about how we deal with it. All viruses are bits of genetic code. They're bundled together inside a collection of lipids and proteins, and that can include a fat-based casing known as a viral envelope. And destroying an envelope virus such as SARS-CoV-2 takes less effort than their non-enveloped compatriots, such as norovirus, which can last for a month on surfaces. So that's good news for us. Envelope viruses typically survive outside of a body for only a matter of days and are considered among the easiest to kill because once their fragile exterior is broken down, they begin to degrade. So again, it makes our job a little bit easier than having a non-envelope virus. So what about survival on surfaces? Well, a fair bit of work has been done on this, and human coronaviruses survive on inanimate objects and remain viable for up to 4 days at temperatures of 22 to 25 degrees C and a relative humidity of 40 to 50%. So that's typical of air-conditioned indoor environments. Survival on environmental surfaces is also dependent on the surface type. And so studies have shown the following reported viabilities: 72 hours on plastic, 48 hours on stainless steel and glass, 24 hours on cardboard, cloth and wood, and 4 to 8 hours on copper. They've also found that the risk is significantly reduced after 72 hours. And for buildings unoccupied for 7 days or more, they will only need normal routine cleaning prior to reopening, as SARS-CoV-2 has been shown not to survive on surfaces longer than this time. So the ones that we're particularly interested in are obviously the stainless steel and plastic and the hard surfaces, which I'm going to talk about in a minute. So what's the approach been in the UK? Well, it's been to undertake a 2-part cleaning process. So first of all, we have a cleaning process which helps to remove the pathogens, and that significantly reduces the load on the contaminated surfaces. And it's an essential first step in any disinfection process. So cleaning alone with the water, soap or neutral detergent and brushing or scrubbing reduces dirt and debris and other organic matter, but it doesn't kill microorganisms or viruses. So disinfection in the UK is also required, and that's using 100 milligrams per litre solution of available chlorine. There are instances where a thousand milligram solution of available chlorine. There are instances where that is considered too strong for the surface that you're cleaning, and so alcohol wipes may also be used, provided they contain at least 70% ethyl alcohol content. So, just given the 1,000 milligrams per litre solution of chlorine, that there are issues that arise from the consequences of that within the swimming pool environment. So we've got things that we need to consider, like a strong chlorinous odour is going to be left, exposure of bathers to the chlorinated surfaces, the effect on stainless steel, stress corrosion, cracking and chloride pitting, and the cleaning of swimming aids and inflatables. So if we first consider the poolside and changing room walkways and hard surfaces, The way we've approached it within the UK is that when swimming reopens, and we believe it's probably going to be the 4th of July, the pools, when they reopen, will session the swimming programme. So in areas within the swimming pool will be open for use and closed after use to bathers. And so that's to enable cleaning and disinfection. And so it will occur on a zonal basis. So they can be cleaning a closed area while another area is open. All hard surfaces will be cleaned with a detergent, i.e. hot soapy water, and that's to first remove the dirt and maximise the quantity of available chlorine to disinfect against the virus if it were present. This also prevents the formation of disinfectant byproducts because you've removed the precursors present to prevent the formation. So the detergent clean surface is then rinsed with fresh water and allowed to air dry before being wiped over with a solution of 1,000 milligrams per litre available chlorine solution. And then we say they can leave to air dry for an hour or alternatively rinse the area with water after the hour contact period. The chlorinous odour will subside with drying or dilution, but equally it gives reassurance to the user that the area has been cleaned. So why 1,000 milligrams per litre available chlorine for disinfection? Well, we simply do not know whether or not any of the pool users are symptomatic or asymptomatic. We would like to think that no symptomatic people will arrive to use the pool, but quite often that they are unaware in the first couple of days that they are actually infected with the virus, and so simply would not know and wouldn't necessarily show up with temperature testing. So there's little point in taking body temperature at the time of entry because we can't determine this. So therefore, we have to assume that there is the potential for the SARS-CoV-2 to be introduced into the pool changing areas, toilets, pool halls, and pool water. So we're really adopting a belts and braces approach. So what about stainless steel fittings and handrails? Well, we can't clean stainless steel fittings and handrails with 1,000 milligrams per litre available chlorine solution. And that's because you get the issue of chloride pitting and surface corrosion, and you can also expose it to disinfection byproducts which have been associated with stress, corrosion, cracking. So instead, we recommend that the stainless steel surfaces are wiped over with 70% ethyl alcohol wipes at least twice a day. Obviously, those handrails that are below the water level won't receive any additional cleaning. They'll just simply be washed over by the pool water. Stress corrosion cracking of stainless steel suspended ceiling hangers has primarily been shown to be associated with condensation of the air from the pool hall atmosphere on the stainless steel, resulting in the concentration of chloramines and subsequent attack. And the odour associated with chloramines in the pool hall atmosphere is quite distinctive. You get a sweaty socks-like odour that is readily determinable from that of free chlorine. So chloride pitting of stainless steel surfaces is primarily associated with water containing chloride, and that condenses on the stainless steel surface, evaporating and concentrating the chlorides. So daily wiping over of such surfaces prevents such corrosion occurring, and hence why we recommend using the 70% ethyl alcohol wipes for that purpose. So what about buoyancy aids and inflatables? Well, the problem with buoyancy aids, particularly with floats and noodles, is that they're produced from an open-celled ethylene propylene diene monomer, which allows water to be retained within the structure. However, the risk of contamination in this situation is considered greater from the external surfaces from the float than from the open-celled area. So pool water chlorination reserves are insufficient to deal with the potentially contaminated surfaces from saliva, mucus, etc. And we're not only talking about viruses here, we're also talking about things like Pseudomonas aeruginosa and skin infections associated with that. So PUTAG advises that after each use, the buoyancy aid should be submerged in a solution of 100 milligram per litre chlorine for 1 hour. So that's 10 times less than cleaning of other surfaces. It's then rinsed off with mains water prior to use. And the reason it's less is because of the potential detrimental effect on the fabric of the buoyancy aids. And in respect of inflatables, PUTAG recommends that they aren't used. Several reasons. Inflating them creates aerosols. It's almost impossible to maintain 2 metre distancing. Sliding down them results in skin abrasion and surface contamination, and they can't be kept clean very easily. And their use creates enhanced splashing and hence aerosol formation. So the question's been posed, well, what about hydrogen peroxide for cleaning buoyancy aids? Well, some countries require you to have a license to purchase, so you need to check your local regulations, and that's because of its use in the formation of explosives. It's effective against SARS-CoV-2, but is only recommended as suitable for non-porous surfaces. Therefore, you can't use it on open-cell EPDM materials. It also oxidises the DPD number 1 test, which we use for testing for chlorine, giving a red colour. So it may suggest that you've got more chlorine present if it got into the pool water, and we wouldn't want that. And also it's far simpler to keep to the same chemical for disinfection throughout, because it's less complicated for the user to remember and follow the instructions. Thank you.